Hello, everyone. Welcome back. So, today I'm going to be talking about the first differences and partial and direct variation. So, just in general, the characteristics of linear equations. So, right now we're actually doing a homework take up for this part here. Last time we went over number one, two, and three, and this time I'm going to go over, we'll see how much of it, but at least four, five, and six. I want to get some more homework take up out of the way here. Okay, so this one here says the temperature at which water boils depends on how high up the water is relative to the sea level. The recorded data, boiling point and altitude, are recorded on the graph. Examine the graph and answer the questions below. The value of the y-intercept is what? Well, let's see. Well, y-intercept, what is that? That basically means where does the axis touch, where does the graph touch the y-axis, right? So the vertical axis. So that would be right here at 100. So the answer for what is the y-intercept is y-intercept is 100. What does the y-intercept represent in the situation? Well, let's see. It means, in general, the y-intercept is when x is 0, what is y? So in this case, x is altitude. So when the altitude is 0, what is y? What is the boiling point? So basically, it expresses the initial boiling point in degrees Celsius. In degrees Celsius before we've actually gone any distance above the sea level. Okay. Does the graph represent direct or partial variation? So this graph represents partial variation because the y-intercept is not 0. If the y-intercept is 0, then it's direct variation. But because the y-intercept is 100, which isn't 0, it would be partial variation. So let's write that down. Partial variation. And then it says to find the slope of the line and explain what the slope represents in context of the graph. So just a reminder, how do we find slope? Well, slope, or m, is equal to rise over run. So what's the rise in this situation? Well, let's see. It's -4, right? We go from 100 down to 96. So that means we're going down 4. So -4 on the top. And what's the run for that -4? Well, let's see. It's 1,200. So the answer is -4 over 1,200, which actually I believe can be reduced to -1 over 300. So there's our slope. So um, our slope would be -1 over 300 in this case. It also asks, what does the slope represent in this situation? Basically, what does the slope represent? It represents the altitude, right, per degree Celsius, so to speak. Right, so let's kind of consider that. If we know that we go down 4 degrees Celsius for every 1,200 meters, that means we go down 1/300th of a degree Celsius for every meter of altitude, right? And so this represents the degrees Celsius for every 1 meter of water. Good. Which is very little, right? It's only 1/300th of a degree Celsius. But if we think about it, that makes good sense because here we're only going down 4, and then over here, this scale is all the way to 1,200, right? That's a really, really big number. And so clearly it's going to be a very small fraction of of a degree Celsius for every 1 meter, right? Because to even go down 4, which doesn't seem like a big number, we're changing the altitude by 1,200, right? That's pretty big. So these numbers may seem a little off to you, and that's okay. They're actually not off. This is not a mistake. These are the true numbers, even though it does seem pretty far-fetched. When I should say down, right? Because it's negative, so that means it's down 1/300th of a degree Celsius. Good. The equation of the line is what? So for this one, this is simple because we just use our answers from A and D. Remember that B is the y-intercept, which we said was 100, right? So plus 100 at the end. And then M is the slope, so that's -1/300. And then X and Y just stay as is, so that's good to go. Okay, use the equation to find the boiling point of water at an altitude of 6,500 meters and 8,000 meters. So again, altitude is the x coordinate, right? And so we're going to plug these numbers in as x and solve for y. So in this case, y is going to be equal to -1/300 times 6,500 plus 100, and that's going to tell us the altitude. So let's do that. What is -1/300 times 6,500? Okay, well, that's 21 and 2/3. And then we add 100 to that, and we get 121 and 2/3. So I'll just round to 0.67. And that's going to be our boiling point in degrees Celsius. Good. Now let's do the same thing with 8,000. So y is equal to -1/300 times 8,000 plus 100. Oh, my apologies. I have done this incorrectly over here. This one, so 6,500 divided by 300, and then we're adding 100 too. So I was adding them both as though they were positive. It was not positive. So actually it should be 78.33 if we round off. My apologies. Okay. Anyway, so 8,000 divided by 300 negative, and then we're going to add 100 to that, and we get 73.33. And it might seem like, oh, well, that's a big difference in distance. That doesn't seem like that big a difference in our altitudes, or in our boiling points, rather. But the thing is, given how not very steep the slope is, this actually makes some good sense. Even though it's only 1,500 more, it's only going to have a very minimal change here. And so this is good. This is not incorrect, I don't think, based on that, even though it does seem like, oh, that's not that big of a shift. That's okay that it isn't. Okay, now we want to know, let's use the equation to find the altitude if the boiling point is 70 degrees or 62. So in this case, we're going to sub in 70 for y, because now we're being told the number of degrees, and we need to find the boiling point. We need to find now the altitude. Yes, we need to find altitude in meters. So 70 is equal to -1/300x plus 100. Okay, so now we're going to subtract 100 from both sides. Over here, we're going to get -30 is equal to 1/300x, and then 30 times 300. And its negative is going to give us that x is equal to -9,000. All right, very good. All right, this next one says, use the equation to find the altitude if the boiling point of water is 62 degrees. All right, so let's do that. Oh, you know what? This should be negative here. And so actually we're going to end up with positive. I was thinking there must be something wrong because the answer should be positive, and it is. There we go. Okay, so 62 is equal to -1/300x plus 100. And then let's do 62 minus 100, and then 100 minus 100 to get -38 equals -1/300 x. And then we have that the answer is going to be x equals 11,400. And there's our answers. And we could put meters there as well. Awesome. Okay, let's move on to number 5 from the homework. Number 5 says, during the Christmas break, an experiment was performed to discover the different times it takes a turkey to cook, given the turkey size. The graph below displays the cooking times for different sizes of turkeys. Examine the graph and answer the following questions below. So, first one is again, what is our intercept here? So, our first part of the question asks, what is our value of the y-intercept? And that's going to be 15, right? Where does this touch our axis here? It touches at 15, so it's 15. What does it represent? Well, it says that when the mass in kilograms is 0, the cooking time is 15 minutes. And so for a very, very small turkey, apparently, where the mass is 0, when the mass is 0 kilograms, then the cooking time is 15 minutes. Does this graph represent direct or partial variation? So again, this would represent partial variation because the y-intercept is not 0. So we will say partial variation, and that's the reason. I didn't actually ask for the reason, but I did want to give the reason why as well. The next one says, find the slope of the line and explain what the slope represents in the context of the graph. So let's see. So again, slope is rise over run. In this case, the rise is, looks like 60. Yeah, the rise is 60 over the run, which is 2. So therefore, the slope is 30. Now it asks us to say, well, what does it represent in the situation? Basically, it represents the number of kilograms, or the amount of cooking time per kilogram. So it's the cooking time per kilogram, right? So every time that we increase the kilograms by 1, right, every time we cook an additional kilogram, then how many additional cooking time minutes do we need? And it's 30, right? So if we added, 10 kilograms, we need 10 times 30 more minutes of cooking time. So that's what it represents in this situation. The equation of the line is y equals mx plus b. So again, let's just do y equals 30x plus 15, right? Because all we're doing here is we're just taking the answer from A and putting it in for the b value, because y-intercept is same as the b value. And m is what we just found in the last part, and that's going to be 30. Then it says to use the equation to find the cooking time of a turkey that is 15 kilograms, right? So kilograms is our x coordinate. So therefore, we put that in for x. So y equals 30 times 15 plus 15, which let's see what that is. If we plug that into a calculator, 30 times 15 plus 15 is 465 minutes, which may seem like a lot of minutes. I recognize that that is actually that's close to 8 hours. I understand that. But generally, a turkey, if you've ever been to a Thanksgiving dinner, it does take a very long time to cook. So yeah. That said, I don't know how accurate this this chart is. This is just for learning purposes here. But for cooking a turkey, it sometimes can take a very, very long time. Okay. Next one is 25 kilograms. So that would be 30 times 25 plus 15. So let's see, 30 times 25 is 750. So that's plus 15, which is 765 minutes that it would take. Then it says use the equation to find the size of a turkey that has a cooking time of these times. So let's start with 400 minutes. So if the cooking time, which is the y value, is 400 minutes, that's going to be equal to 30x plus 15. So first we need to subtract from both sides 15, and we'll get 385 over here equals 30x. And then we'll divide both sides by 30, and we'll get that x is equal to about 12.83. 3 kilograms approximately. And then we do the same thing over here. We'll sub in 220 for y and then solve for x. So first things first, we need to subtract 15 from both sides. So that's going to get us on the left, it's going to get us 205. And on the right, we'll just have 30x because adding and subtracting both, 15 just gets us 0, which is why we're subtracting 15 is to get that 0. And then we're going to divide both sides by 30 and get that x is equal to 6.83 kilograms approximately. Very good. All right, let's move on to the next ones. I think there's just a couple more left. Maybe we'll try to get them all out of the way today. This one says, which type of variation does each graph represent, and explain your answer. All right, so let's answer that. So here it shows Kelly's earnings. It looks like she gets $45. Plus, she gets extra money for every subscription sold. So here we have the y-intercept is not 0, so this would be partial variation. And I won't write down the full justification, but I will say it here. The reason it's partial variation is because it's a straight line, right? It does represent a linear relation here. And it also does not, the y-intercept is not 0, right? The y-intercept is $45. B, estimated bison population in Yellowstone Park. Well, this is not a straight line, so this would be neither partial nor direct. And same thing with justification. I won't write it down, but I'll say it here that my justification for that is that this is not a straight line, right? This does not represent a linear relation. It kind of curves, and so no. This third one here, C, is partial variation. For the same reason as A is partial variation, is because it is a straight line, but the it does not start at the origin, right? At the y-intercept is not 0. It looks like the y-intercept is some number that's above 2,400 at the very least. So there we go. And then here's the cost of buying perennials. Okay, which sounds like that's number of plant by the looks of it. And looks like this would be direct variation because the y-intercept is 0, so therefore it would be direct variation. So that's why. Okay, let's move on to question number 7. Question number 7 says, a rain barrel full of water is drained at a constant rate. Data for the first few points of draining is shown on the grid below. After 6 minutes, the draining is stopped. Find the slope of the relation and use it to plot 2 more points and find how much water is needed to refill the rain barrel. Okay, so that's a lot. So let's break this down. First thing it says is find the slope of the relation. So that's what I'm going to do first. I'm going to find the slope. So m is equal to rise over run. So let's see, the rise is going to be, it's going from 100 to 85. So that's negative 15 for rise, right? Over run, which is 1. So therefore the slope is negative 15. So that's the first thing. Check. We did it. Okay. And then it says, and use it to plot 2 more points. So let's use that slope to plot 2 more points. We're going to plot one here. We're going to go down 15 and over 1, and then down 15 and over 1 again. So there we go. We plotted our 2 more points, so check. And then it says, find how much water is needed to refill the barrel. Well, if we assume that the barrel, because it actually, I think it should have perhaps told us, I believe it should have told us what the full volume would be. But it says here, volume left in the rain barrel in liters versus the time, because it's draining at a constant rate. If we assume that the full capacity is 100 liters, we want to know how much water is needed to refill it. So what would we have to do to to get it back to that 100 meter or 100 liter mark. So let's say 100 liters is a full barrel, and looks like we went all the way down to 10, right? And after 6 minutes, there are only 10 liters left, right? So therefore, 90 liters are needed to refill the rain barrel. So with a question like this, my best recommendation is break it down into parts, because it can seem overwhelming when it says find the slope and do this and do this. Break it down and say, okay, what's the first thing they asked me to do? Let's do that. When that's done, then do the second thing and then the third thing, because oftentimes you'll need the first part to get the second part, right? We needed to know the slope in order to be able to plot 2 more points, and then we needed to plot 2 more points in order to figure out how much water would be needed to refill that rain barrel. Good. Okay. All right, let's move on to number 8. There's just number 8 and 9 left. Looks like, yeah, just number 8 and 9. So I'll do those, and then we'll be done for the day. Here it says, Rachel plants trees in Northern Ontario. She is paid $55 a day plus 15 cents for each tree she plants. On the grid provided, draw the graph of the relationship between Rachel's total earnings for a single day, E, in dollars, and the number of trees that she plants that day, N. Include a scale on the vertical axis. Okay, because it looks like they already included a scale on the horizontal axis. We need to include the scale on the vertical axis. So it says here for part A, to find the earnings for a single day for n equals 50, 100, 150, and 200, and to plot those 5 points on the graph first. So let's do that. First off, we need to know an equation for this. And so it says she's paid $55 per day, right? So that means B is $55 plus 15 cents for each tree she plants. And X represents the number of trees she plants, right? So this is like our X and this is like our Y, right? And so let's figure out how much money does she earn for n equals 0, or in x equals 0, or you know what, we'll just say n and e instead of x and y. But we're going to treat e just like we normally treat y, and then n like we normally treat x. So for n equals 0, e would equal to 55, right? For n equals 50, e would equal to 0.15 times 50 plus 55, which is what? Let's see. Let's see here. 0.15 times 50, which is 7.5, plus 55 is 62.5. Good. And then we have n equals to 100, so that's going to be e equals 0.15, so 15 cents times 100 trees that she's planted, plus 55 is going to equal to, let's see, 15 plus 55, which is $70. Let's say she plants 150 trees. That's going to be times 150 plus 55. 77.5. Excellent. And then n is equal to 200, would mean e is equal to 0.15 times 200 plus 55. So that's like 30 plus 55, which is 85. So there we go. So now let's plot these points on the graph, but first we need to do a scale for total earnings. So let's talk about how we might approach this scale. Like, how do we know what scale to make it, basically? Well, we know that E starts at 55, and E ends at 85 in terms of the values we have. So we need a scale that's going to get all the way up to 85. So if we do maybe 10, 20, 30, 40, 50, 60, 70, 80, and a 90 there, then that way we have a good scale that's in tens, which are easy to work with. I always recommend choosing fives, tens, ones, numbers like that that are easy to work with, that aren't too challenging, just so it makes it easier to plot your points accurately and you're not kind of guessing as to where things are as much. It's a lot easier when we do it in like tens, that sort of thing. So, yeah, I think this is probably the most appropriate scale there is. That said, I would accept other scales too. It's just that I feel this scale makes the most sense given our context here. All right, so for n is equal to 0, the answer is 55, we said, right? And actually, let's write down what we discovered into our table. So here I'm just copying the numbers that I got earlier and putting them in the table. And what's the second number? It's 50 and 62.5. So 50 is half of 100, which is there, right? And then same with 150, right? That's halfway between 100 and 200. So 50 and 62.5. So let's see, here's 60 right there. So 62.5 would be right there. And then there's 170. So 170 is right there. And then there's 150 and 77.5. Okay, so there's 75, 77.5 is right there. And then 285. Okay, so 285. That. Oh no, I think that's 90 actually. I think I plotted that wrong. Yep, there we go. I didn't quite get it right. Okay, there we go. Now I think we got it right. So now I'm just going to draw a nice straight line through there, and that should represent a nice straight line if we've done it correctly, which it does. So that's good. Okay, let's see what's next. It says find the y-intercept. Well, we already know the y-intercept is just what is the y value when x is 0, which is 55, so we can just say 55. Find the slope or the rate of change. Well, we know that slope is equal to rise over run, and we know that the rise is 7.5, or sorry, the rise is from here to here. So yes, that looks like it's 7.5 over the run, which is 50. So 7.5 over 50, which is actually the same as 15 over 100, or about 0.15. So if you prefer a slope in decimal form, that would be a good decimal form there. And then it says write an equation to represent the relationship between Rachel's earnings for a single day and the number of trees she planted. Well, we've already done that, right? We've already done that in order to figure out where to plot our points, right? We need an equation to be able to plot the points properly. So that would just be that E is equal to 0.15 times n, right, times the number of trees she plants, plus 55. And so there we have it. Okay, let's see. I think there's just one more. So I know it's getting kind of long, but that's okay. Let's just do one more, and then I promise this will be it for today. This next one says Lucia and Paul each have a plant. Both plants grow at a constant rate. Lucia records information about the height of her plants in a table, and Paul graphs his results as shown below. So it looks like on day 4, the plant has reached height 8. By day 7, 10, and then by day 10, the plant, reaches 12, and then by day 13, the plant reaches 14 centimeters. So here it says to plot Lucia's information. So it actually looks like it is already plotted, is it? No, actually, let's see. Day 4, it's 8. So that would be here. And then day 7 would be 10. So that's here. And then, oh, I see, because this is Paul's plant. So now we're doing Lucia's plant, and we're going to compare the two. Okay. And then after after 10 days, it's 12 centimeters. Okay. And then after 13 days, it's 14 centimeters. Okay. Okay, so there's Lucia's plant, and then the other ones are for Paul's plant. Okay, and actually I'll highlight them. Let's do green for Paul's plant and yellow for Lucia's plant. Oh, oops. There we go. This is Lucia and Paul, just so we remember. And then it says to draw a line of best fit for Lucia and Paul. Well, I guess we did that. I'll draw some arrows here, but these are good enough lines of best fit that just kind of go through all the points. Find the rate of change for Lucia and Paul. Okay, so I want to keep it point out here. This is going to be two separate ones we're going to do here. So let's do the slope for Paul, and then we'll do the slope for Lucia. So the slope for both will be rise over run. So let's get that out of the way. So for Paul's plant, looks like we're rising how much for every run? Well, the run goes from 10 to 14, which is 4. So the run is 4 for Paul. And the rise is from 7 to 11. So that's 4 as well. Doesn't look like 1-to-1, but you know what? It's because the scales are different. That's why. That makes sense. So therefore, the slope for Paul is 1. So that actually is correct, even though it doesn't look like it, just because of the way the x and the y axis are scaled in this example. For Lucia, let's see. Well, it goes over, the run is 3, right? We go up 3 days each time, and then it goes up 2 in height, so it's 2/3, right? Then it asks, whose plant is growing faster, Lucia's or Paul's? Well, Paul's plant is going faster because his slope is bigger, right? 2/3 is a smaller number than 1, and therefore Paul's plant is growing faster. We can also just see on the graph, like it looks like Paul's plant is growing faster. If we look at how steep the line is, like which line looks like it's a steeper slope, Paul's just looks like it's steeper, right? It looks like it's growing faster as well, right? You'll notice here too that Lucia's actually starts at a higher point than Paul's over here, but by this time, Paul's is gaining on Lucia's, and if we were to continue Lucia's line, eventually Paul's would surpass because Paul's plant is growing at a faster rate. So eventually, Paul is going to catch up and then surpass Lucia's plant because it's going up at a more steep rate, at a steeper slope. All right. And it says justify your answer by using both plants' rates of change. Well, makes sense. We did. We said that the rate of change for Paul was 1, which is greater than Lucia's rate of change. So that is one reason why. The other reason is we can look at it on the graph as well and recognize that there too. All right. Well, that is it for our lesson today. Next time we'll continue with something different. Good work with the homework, and we'll see everyone next day. Bye, everyone.